In a daring announcement, scientists claim to have discovered a new planet unlike anything previously known. NASA, renowned for its groundbreaking findings, has revealed that this planet is fascinating not only because of its size and location but also due to the light it displays, which appears to be artificial. This discovery raises profound questions. Are we on the verge of uncovering secrets that could transform our understanding of the universe? Could this finding indicate the existence of life on other planets? By delving into NASA's remarkable discoveries, we may soon learn the truth about these extraordinary lights. In 2007, NASA launched the Dawn spacecraft on a mission to explore some of the most intriguing objects in our solar system. Equipped with 3 ion engines, Dawn embarked on a journey beginning with a 14-month study of Vesta, the second-largest asteroid in the asteroid belt. During its time there, Dawn transmitted detailed images and data that revealed Vesta's complex surface and diverse geological history. After completing its mission at Vesta, Dawn began the second and perhaps most exciting part of its journey, a detailed study of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and head toward Ceres, a feat traditional chemical propulsion could not achieve. These engines provided a gentle yet steady thrust that allowed Dawn to travel great distances and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For many years, it was considered the smallest planet in our solar system until its reclassification as a dwarf planet in 2006. With a diameter of approximately 950 kilometers, Ceres is the largest and most massive body in the asteroid belt. It is also one of the most fascinating due to its unique characteristics. Scientists eagerly awaited the first detailed images of this mysterious world, which revealed bright spots scattered across its surface, particularly within a large crater known as a crater. These bright spots sparked immediate interest and speculation within the scientific community. Before dawn, the best image of Ceres was a blurry, low-resolution snapshot taken by the Hubble Space Telescope. Very little was known about this dwarf planet, and the prospect of finally getting a close-up view promised groundbreaking discoveries. The Dawn mission aimed to enhance our understanding of the solar system's formation and the role water played in the evolution of planetary bodies. The bright spots on Ceres, also observed on other asteroids, could be composed of highly reflective materials, possibly salts left behind by sublimated water. This discovery suggested the possibility of cryovolcanism on Ceres, a process where volcanoes erupt liquid water or brine instead of molten rock. But what exactly are these mysterious lights, and what do they reveal about the nature of Ceres? Could they indicate ongoing geological activity, or are they evidence of something even more extraordinary? Ceres stands out among other bodies in the asteroid belt due to its size, mass, composition, and potential to contain water and ice. Unlike typically rocky asteroids, Ceres has a more comet-like composition, suggesting it may hold secrets about the early solar system. After 2 years in transit, the Dawn spacecraft began its approach to Ceres in early 2015, marking an important milestone. As Dawn drew closer, the images of Ceres became increasingly detailed, revealing a world previously shrouded in mystery. The first images showed a cratered surface indicative of a long history of impacts. What captured the attention of scientists and space enthusiasts alike were the mysterious bright spots scattered across the dark, rocky terrain. As the resolution of the images improved, scientists formulated theories about the nature of these bright spots. Were they patches of ice reflecting sunlight, or could they represent something even more exotic? Speculations ranged from mineral deposits to potential signs of cryovolcanic activity. To everyone's surprise, closer inspection revealed that the brightest spots were not single entities but clusters of several distinct spots. The most widely accepted hypothesis was that these were deposits of salt left behind by the sublimation of water. This finding suggested that Ceres had, or still has, some form of geological activity capable of bringing water or brine to the surface, where it quickly evaporates, leaving behind bright, reflective residues. These discoveries challenged existing notions about Ceres, painting a picture of a more dynamic and complex world than previously imagined. The possibility of groundwater or brine pockets could have profound implications for understanding the potential for life in our solar system. Ceres is an intriguing dwarf planet often described as an icy world with a rocky but porous surface. Unlike most asteroids, which are composed primarily of rocks and metals, Ceres is notable for its unique composition. Its surface is a mixture of water ice and hydrated minerals, including clays and carbonates, which give it a less dense structure than its rocky neighbors. This composition suggests that Ceres contains a significant amount of water. Ceres's surface layer is rocky but porous, with ice and other volatiles trapped within, making it more similar to a comet than a typical asteroid. The dwarf planet is believed to have a distinct interior composed of a mud mantle and a core rich in water ice, which accounts for approximately 50% of its total volume. Ceres's mantle likely consists of a mixture of rock and brine surrounding a core of denser materials such as silicates. The presence of a significant amount of water ice suggests that it may have hosted liquid water in the past, especially if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from its neighboring asteroids and raises intriguing questions about its potential for geological activity and the role of water in its evolution. The discovery of ammonia clays on Ceres further suggests that the dwarf planet may have formed in a cooler part of the solar system before migrating inward. The presence of ammonia could lower the freezing point of water, supporting the existence of surface brines. These insights into the composition and history of Ceres not only enhance our understanding of this fascinating dwarf planet, but also provide valuable clues about the processes governing the formation and evolution of icy bodies throughout the solar system. Cryovolcanism, a fascinating and relatively rare geological process, plays a significant role in understanding Ceres. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, expel materials such as water, ammonia, or methane. These substances can exist as liquids or gases in extreme cold environments where cryovolcanoes are found. On Ceres, cryovolcanoes allow salty water to reach the surface. Upon contact with the vacuum of space, the salt water rapidly sublimates, transitioning directly from a liquid or solid state to a gas. This process leaves behind glistening, reflective deposits of salt. These salt residues form the mysterious bright spots observed on Ceres's surface. The most famous of these bright spots is located within a crater. This area has garnered significant attention due to its high reflectivity and periodic hazes observed by the Dawn spacecraft. These hazes are believed to result from water sublimation, suggesting that cryovolcanic activity may still be occurring or has occurred relatively recently on Ceres. In addition to the bright spots in a crater, Ceres hosts several other bright spots scattered across its surface, each with its unique characteristics. This distribution indicates that cryovolcanism may be a widespread phenomenon on Ceres. The presence of these bright spots underscores the dynamic and active nature of Ceres, challenging earlier assumptions that it was a geologically inactive world. As the Dawn spacecraft returned increasingly detailed images, a wide variety of surface features began to emerge. Ceres's surface is dotted with numerous craters, each telling a unique story about the dwarf planet's history. These features reveal a complex and evolving world, full of mystery yet to be unraveled. Ceres's bright spots, particularly those in a crater, continue to intrigue scientists and redefine our understanding of the dwarf planet's active geology. Detailed observations suggest that the reflective material in these spots is primarily composed of sodium carbonate, a type of salt that hints at past or present liquid water activity beneath Ceres's surface. The discovery of such compounds reinforces the idea that Ceres harbors a subsurface reservoir of briny liquid. This reservoir might occasionally seep to the surface through fractures in the crust, a process facilitated by the dwarf planet's relatively low gravity. Once exposed to the vacuum of space, the briny liquid quickly sublimates, leaving behind the highly reflective salts. This process not only accounts for the dazzling bright spots but also points to a dynamic internal structure. Further investigations have revealed that the bright spots in a crater are not merely static remnants of past activity, but could be evidence of relatively recent or ongoing processes. The periodic hazes observed above the bright spots are believed to result from water vapor emissions, possibly triggered by sublimation or even weak cryovolcanic activity. This finding is groundbreaking, as it suggests that Ceres may still possess internal heat sources capable of driving such activity, albeit at a much slower and less dramatic scale than Earth's volcanoes. These processes provide critical clues about the evolution of icy bodies and the potential for habitability in environments once considered too cold and inert for life.